Europe's most closely watched volcano just broke its own record, and the number that actually matters isn't the one you'd expect. It isn't the magnitude of the earthquake. It's a movement of the ground measured in centimeters, a permanent shift the instruments had never recorded in more than 20 years of constant watching. One station near the harbor lurched 3 centimeters sideways toward the sea in a single instant. Everything around it moved about 1. And then, in a single quiet line buried in a technical report, the observatory noted something that changes how you should read this entire event. If you want to understand what's really happening beneath the ground where 500,000 people live, and not the panic version, stay with me and think about subscribing, because by the end of this, you'll see what almost everyone reporting on it missed. Let's start with the night it happened. On Friday, July 31st of 2026, at around 7:45 in the evening local time, a magnitude 4.7 earthquake ruptured beneath the western edge of Naples, Italy. The epicenter sat inside a place called the Campi Flegrei caldera, directly under the town of Pozzuoli. The rupture was shallow, only about 3 kilometers down, roughly 2 miles, and shallow quakes deliver their energy almost undiminished to the surface. So the shaking hit hard. That earthquake set a record. It was the strongest event ever recorded at this caldera since scientists began instrumentally monitoring the system, and one of the strongest tremors felt anywhere in the region in about 4 decades. It surpassed a pair of magnitude 4.6 events that had already struck during the previous year. Around 26 people were injured. Trains halted across the Naples network. The port of Pozzuoli closed. Ferry passengers bound for the islands of Ischia and Procida were left stranded on one of the busiest travel weekends of the entire Italian calendar. All of that was reported at the time. And if that were the whole story, this would just be a video about a moderate earthquake in an unlucky place. But it isn't the whole story. Because in the weeks that followed, Italy's National Institute of Geophysics and Volcanology published its routine monitoring bulletins for Campi Flegrei. These are dry technical documents that come out on a regular schedule, and almost nobody outside the volcanology community ever reads them. Buried inside were recalculated numbers describing something the instruments at this caldera had never once had to describe, not in more than 2 decades of continuous measurement. The ground didn't just shake on July 31st. The ground moved permanently, and the network caught every millimeter of it. To understand why that matters, you have to understand why this place is wired up like almost nowhere else on Earth. The reason is a phenomenon called bradycism. Bradycism is the slow rise and fall of a caldera floor, and at Campi Flegrei, it isn't a historical curiosity in a textbook. It's the defining fact of daily life in Pozzuoli. Since around 2005, the floor of this caldera has been rising, not in sudden jumps, but continuously, month after month, year after year for roughly 2 decades. To track that, the observatory runs a permanent network of satellite positioning receivers cemented directly into the ground across the caldera. Each one reports its own position in 3 dimensions, continuously. If the ground a station is bolted to shifts, the station shifts with it, and the record shows it, millimeter by millimeter, in bulletins anyone can download. For all those years, that record has been dominated by a single signature. Slow, steady, mostly straight-up inflation. A rising line on a graph, patient and relentless. But during the earthquake swarm of July 31st, several stations in the central part of the caldera recorded something categorically different. The instruments and the rock they're anchored to physically jumped during the quake, and the jump was large enough to appear in the position record as a clean, sharp step rather than as background noise. And crucially, it showed up on both the horizontal and the vertical measurements at once. Here's why that distinction matters so much. Bradycism is slow, continuous, and driven by the volcanic and hydrothermal system deep underneath. A jump like this, what scientists call a co-seismic offset, is instantaneous, produced by the rupture itself, the elastic snap of the crust when a fault slips. Those are 2 completely different physical processes, and now they were both sitting in the same instrument record, at the same volcano, at the same moment. And they did not point the same way. Let me give you the actual numbers because they tell the story. Across the central caldera, the stations recorded a horizontal jump of roughly 1 centimeter, mostly toward the southwest. Those same stations also recorded a small vertical drop of about 1 to 2 centimeters. And then there's one station that refuses to fit the pattern. It sits at Rione Terra in the historic center of Pozzuoli, just a few hundred meters from the harbor, and it's the single most important reference point in the entire monitoring effort, because it sits directly over the spot where the caldera has been deforming the most. That station recorded a horizontal shift of about 3 centimeters to the southwest, 3 centimeters against 1, a factor of 3 between the reference station and its neighbors a short distance away. And here's a subtle detail worth pausing on because it flips your intuition. Every one of these measurements carries the same margin of error, a couple of millimeters. On a 1 centimeter signal, that's a fairly large uncertainty, around 20%. But on the 3 centimeter signal at Rione Terra, that same margin represents less than 7%. So the outlier isn't the noisy, unreliable measurement here. The outlier is actually the most statistically solid number the whole network produced. The station that has spent 2 decades recording the fastest rise in the caldera is also the station that recorded the biggest sideways lurch during the largest earthquake in the caldera's instrumental history. That is almost certainly not a coincidence, and it's the most useful piece of geometry in this entire story. Now, why did that one station move 3 times as far? Honestly, it isn't settled, and I want to be straight with you rather than pretend. There are 2 leading explanations, and nobody has published which is correct. Either that station simply sits closest to the fault structure that actually slipped, and so recorded the largest nearby offset for that reason. Or it sits on ground that behaves differently, a coherent block of tough, welded volcanic rock that responds to shaking differently than the softer material around it. Those 2 explanations aren't even mutually exclusive. What would settle it is a precise, relocated map of exactly where all the small quakes happened underground, and that work hasn't been published yet. But the direction of the movement is worth stating plainly because it's consistent, and consistency tells you something. The whole network moves southwest. The Rione Terra station moves southwest. Both point the same way, seaward, toward the Gulf of Pozzuoli. The caldera floor didn't scatter in random directions the way it would if these were just isolated local quirks at individual stations. It moved coherently in one direction, toward the water. And while it slid sideways, it also dropped. Put those 2 facts together, outward and seaward horizontal motion plus a small vertical drop, and the most straightforward reading is elastic rebound across a fault that slipped in what geologists call an extensional sense. The rock on one side dropped and pulled outward. That reading matches the mechanism worked out for the July 31st quake itself, which was extensional rather than the kind you'd expect from a magma chamber pushing upward and cracking the rock above it. In plain terms, the crust broke because it was being pulled apart, not because something underneath shoved it open. But I have to flag the caveat clearly, because this is exactly the point where speculation usually gets smuggled in and sold as fact. A fault mechanism inferred from a handful of station measurements is a hypothesis waiting to be tested, not a proven result. The observatory hasn't published a formal model of the source, and until it does, the extensional reading is the most reasonable interpretation available, not a finding carved in stone. Still, the geometry isn't even the surprising part of all this. The surprising part is what the ground did afterward. When a sudden step appears in this kind of data, the first thing an analyst does is remove it. The jump is an artifact of the earthquake, a one-time offset layered on top of the long-term signal you actually care about. So you subtract the step mathematically and look at what the underlying curve is doing. The observatory did exactly that and reported the result in a single sentence almost nobody outside the field noticed. Once the jump was corrected for, there were no significant changes in the deformation pattern following the earthquake and its swarm. Read that slowly because it's the whole story. The largest earthquake ever recorded at this caldera occurred. The ground lurched sideways and dropped. And once you take that jump out of the record, the 2-decade-long rise simply picks back up, exactly where it left off, at exactly the rate it was running before, as though the earthquake had never happened at all. The uplift in recent months had been running at roughly a centimeter a month in the zone of maximum deformation, down somewhat from a faster rate the previous winter. So the pace had eased over the winter, but it never stopped. The total rise at the central reference point now measures well over 1.5 meters since this long phase began, climbing week after week. The observatory describes the overall trend as broadly parabolic, a curve rather than a straight line, meaning it's been gently accelerating over the years. And through all of it, the alert level did not change. Italian civil protection has kept Campi Flegrei at yellow, the attention phase, for well over a decade. It wasn't raised after July 31st, and it hasn't been raised since. The standing institutional line is that, based on the current picture, there's no evidence suggesting significant short-term developments. Now we get to the part that actually matters, and it takes a moment of physics, because the conclusion is genuinely counterintuitive. If the ground here were rising because elastic strain was building up in the shallow crust, rock being bent and storing energy like a loaded spring, then a big release event should relieve that strain. The spring unloads, and the uplift should slow, stall, or even partly reverse. That's what a lot of people expected. In the days after July 31st, there was open speculation that a shock that size had released enough pressure to turn the inflation around. It didn't. And it hasn't before either. This wasn't the first magnitude 4+ event of this crisis, and none of the previous ones reversed the uplift. And that non-response tells you something profound. It means the uplift is not being driven by strain stored in the rock above. It's being driven from below by fluid and gas being fed into the system. In that picture, the earthquake relieved stress in the roof of the system without touching the source underneath. And the source just kept on supplying. The roof cracked. The engine kept running. And here I'd love to hear from you. When you weigh those two things, an earthquake that broke a record but changed nothing about the deeper trend, does that make you feel more reassured or more uneasy? Drop your honest reaction in the comments, because scientists themselves sit right on that same knife's edge, and I think the tension is the whole point. There's now peer-reviewed research giving this a physical structure. Work published in the last couple of years mapped the three-dimensional architecture of this caldera and identified a strong arc-shaped layer of caprock roughly 1 to 2 kilometers below the surface, a mechanically tough seal sitting on top of a gas-charged reservoir that extends from around 2 to 4 kilometers down. In that model, the pressure of that reservoir pushing against the cap confining it is what drives the ground upward. And critically, the pattern of the earthquakes suggests the caprock is the first thing to fail, producing exactly the kind of small, shallow quakes this caldera has been generating for years. If that framework is right, then the July 31st event and the sudden ground movements that came with it were events in the roof, not events in the reservoir. And that would explain both mysteries at once: why the earthquake could set a magnitude record and why the long-term rise didn't react to it in any measurable way. That conclusion is reassuring and unsettling at the same time. It's reassuring because an ordinary fault rupture in a caprock is not an eruption and doesn't signal one. It's unsettling because the thing actually doing the pushing was never touched, and it's still pushing on a trend that's been slowly speeding up for years. A centimeter a month sounds like nothing. It's the width of a fingernail, invisible on any human timescale. Stand in Pozzuoli for a week and you'd never perceive it. But run it for 2 decades and it stops being invisible because the built world simply cannot tolerate it. This is where the abstraction ends, and the story becomes something you can photograph. Engineers and risk consultants advising the local government have laid out the damage publicly. The July 31st quake damaged the local aqueduct in multiple places, opening a series of separate water losses and leaving buildings dry. Over the past few years, the slow ground deformation has strained the water, gas, and electrical networks across the area, and the railway has been progressively warped by the uplift, its geometry no longer matching what it was built for. Think about what that means mechanically. A railway is a set of tolerances. A pipe network is a set of tolerances. Every one of those systems was engineered on the assumption that the ground beneath it would hold still. When the land rises unevenly across a whole town, those tolerances get quietly eaten away from underneath until something fails, and then something else fails the following month. And the experts advising the city have gone further than just cataloging damage. They have raised, out loud, the hardest question of all: whether people should gradually be moved away from the most vulnerable neighborhoods, and whether a new long-term plan is needed for the territory as a whole. That's a significant thing for an official advisor to say publicly, and it points at the deeper problem. The engineering conversation and the housing conversation are the same conversation, and neither one has a clean answer. The single clearest demonstration of what Bradyism does is the harbor itself, and it's worth a minute because it makes the number physical in a way nothing else can. The quays at Pozzuoli have risen more than 1.5 meters relative to the sea. Not because the water dropped, but because the land rose, carrying the concrete up with it. A harbor is fundamentally a fixed set of relationships. Between a quay and a ferry deck, between a loading ramp and a vehicle, between a hull and the water beneath it. Raise the land by 1.5 meters, and every one of those relationships breaks at once. The response has been improvised and ongoing. A floating platform was brought into service to compensate for the imbalance and keep ferries running to the islands, precisely because a floating pontoon rises and falls with the sea instead of with the land. Then came July 31st. The earthquake cracked the access lanes to the commercial quays, and the port closed outright, reopening the next day under restrictions. But limits on heavy vehicles kept disrupting the flow of essential goods to the islands, and by the later weeks of August, the situation had escalated toward a genuine threat of supply interruptions unless a solution was found. Proposals under discussion included shifting ferry routes away from Pozzuoli entirely, or granting temporary exemptions, letting heavy trucks cross restricted roads at reduced speed. 2 islands, home to tens of thousands of people between them, and were at that point essentially one logistics dispute away from a supply crisis because of a centimeter a month. And then there's the human ledger, which is the part of this story that never stopped moving. Weeks after the shaking ended, the numbers of evacuated and displaced people were still climbing. Not because anything new had ruptured, but because building inspectors were still working their way through the housing stock, condemning more homes as uninhabitable. Hundreds of evacuation orders, thousands of people displaced, many finding their own accommodation, some in hotels, some in emergency shelters, hundreds of buildings declared unfit to occupy, along with places of worship where crews worked alongside heritage authorities to secure and relocate artworks. That's a slow-motion secondary disaster, running on inspection timescales rather than seismic ones. And it carries a policy consequence that's easy to miss. Every relief measure calibrated on the early figures was calibrated on an undercount. Emergency decrees set up monthly housing support for evacuated families, with extra help for elderly or disabled household members, and funds were allocated against it. But weeks in, a large share of applications still sat unsettled. The frustration on the ground was not subtle. Thousands of people marched through Pozzuoli over the handling of the emergency, at one point briefly occupying a quay at the port and cutting the ferry links themselves, only ending it once they'd secured a commitment to meet directly with a national minister. The mayor was blunt about the pace of the work. The funds, he said, are there. The problem is spending them and actually starting the construction. Money allocated, work not yet begun. So where does all of this leave us, and what are the specific things that will actually tell us something in the weeks ahead? There are 4, and every one of them is checkable. The first is the next full monthly bulletin. The observatory has stated plainly that the ground movement values it published are updated but not yet definitive, and that a final estimate will be recalculated once the best processing and satellite data are available. That definitive set, with the fully corrected long-term curve, will either confirm those 1, 3, and 1 to 2 centimeter figures, or revise them. It's the single most checkable follow-up in this story, and it's due soon. The second thing to watch is whether that 3 centimeter jump at Rione Terra holds. If it stays put, it's a permanent tectonic offset. The ground moved, and it's staying moved. But if it creeps partway back over the coming weeks, then part of it was elastic, and what looked permanent was partly just the rock relaxing afterward, which is common after a rupture. Nobody has published which is happening, and the answer genuinely changes how the whole event should be understood. The third is the uplift rate itself. It had eased to roughly a centimeter a month after running faster the previous winter. If it stays near that lower figure, the slowdown that began earlier in the year is holding. If it climbs back up, that's the long-term acceleration reasserting itself, and it's the number to watch above all the others. And the fourth is the displacement count. When the curve of evacuation orders finally flattens, the true footprint of July 31st will be known for the first time, and only then can anyone say whether the relief was ever sized for the crisis that actually exists. One thing to be absolutely clear about before we finish, because the temptation to overread this is strong. Nothing in the monitoring bulletin says magma is moving toward the surface. Nothing forecasts an eruption. The alert level is unchanged, and the institutional position remains that no evidence suggests significant short-term developments. This is not an eruption countdown, and anyone selling it as one is running well ahead of the data. What the bulletins do say is narrower, and in its own way, harder to sit with. The most closely watched volcano in Europe absorbed the largest earthquake in its instrumental record. The instruments caught the ground lurching sideways toward the sea and dropping. And then the 2-decade rise simply resumed at the same rate on the same curve as if nothing had happened, which tells us the earthquake broke the roof and left whatever is underneath completely untouched. Roughly 500,000 people live inside the high-risk zone around this caldera. The last time it erupted was in 1538, when a new hill pushed itself out of the ground over the course of about a week, after years of the land rising first. Nobody is forecasting a repeat of that, but the honest position, the one the scientists themselves keep returning to, is that nobody can say for certain what stage of this long phenomenon we're currently living through. And that uncertainty, not some hidden secret prediction, is the actual problem. That's the real story beneath Campi Flegrei. Not a doomsday clock, but a patient, powerful process that our instruments can measure beautifully, and our understanding still can't fully pin down, unfolding beneath one of the most crowded coastlines in Europe. The ground will keep rising at whatever rate it chooses, and the next bulletin lands within weeks. If this gave you the clear picture instead of the panic, and you'd rather understand our restless planet than be scared of it, subscribe to W for weather. Hit like so more people find their way past the fear, and tell me in the comments which of those 4 things you'll be watching most closely. I read everyone, and I'll see you in the next one.